Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of physics, which is logic gates, basics of AND or NOT gates. Logic gates form the foundation of digital electronics, shaping how computers and electronic devices process information. These tiny circuits, built using transistors, operate based on binary logic, where every input and output is either a 0 or a 1. By combining these gates in different ways, we can perform complex calculations and decision-making processes essential for modern technology. To understand logic gates, let's begin with the three fundamental types: AND, OR, and NOT. These gates perform simple logical operations that serve as the building blocks of more complex digital circuits. The AND gate is one of the most basic logic gates. It operates on the principle that it produces an output of 1 only if both inputs are also 1. If either input is 0, or both are 0, the output remains 0. Think of an AND gate like a simple electrical switch. Imagine a circuit with two switches in series. Only when both switches are turned on does the circuit complete, allowing current to flow. Similarly, an AND gate allows the signal to pass only when both conditions are met. This is useful in circuits where multiple conditions must be satisfied for an action to take place. Next, we have the OR gate. Unlike the AND gate, the OR gate produces an output of 1 if at least one of its inputs is 1. The output is 0 only when both inputs are 0. To visualize this, consider a room with two light switches connected in parallel. If either switch is turned on, the light turns on. This behavior makes OR gates useful in applications where multiple conditions can independently trigger an outcome, such as alarm systems or sensor-based automation. The third fundamental logic gate is the NOT gate, also known as an inverter. It operates on a single input and simply reverses its state. If the input is 1, the output becomes 0, and vice versa. This gate is crucial for digital circuits as it helps in creating complementary signals and is often used in control mechanisms to negate specific conditions. The AND gate is a fundamental gate that outputs a high signal only when all its inputs are high. If any input is low, the output remains low. This makes the AND gate useful for decision-making circuits, where an action is triggered only when multiple conditions are met. The OR gate, in contrast, produces a high output if at least one of its inputs is high. It only gives a low output when all inputs are low. This gate is essential in systems where an action can be initiated by multiple conditions, such as alarm circuits that activate when any one of several sensors detect an issue. The NOT gate is unique because it has only one input and reverses its signal. If the input is high, the output is low, and vice versa. This simple but powerful gate is widely used in circuits to invert signals and create logical conditions in more complex systems. These three basic gates form the foundation for more advanced gates like NAND, NOR, XOR, and XNOR, which are used in processors, memory storage, and control systems. By combining logic gates in different configurations, engineers design circuits that perform arithmetic operations, store data, and execute instructions in digital devices. By combining these three basic gates, more complex logic circuits can be designed. For example, NAND and NOR gates are variations of AND and OR gates, respectively, but with inverted outputs. The NAND gate, a combination of and followed by NOT, outputs 0 only when both inputs are 1. In contrast, the NOR gate, which combines OR with NOT, outputs 1 only when both inputs are 0. These gates are widely used in memory circuits and microprocessors due to their versatility. One of the practical applications of logic gates is in digital decision-making systems. Take automatic streetlights as an example. Sensors detect ambient light levels, and based on logical conditions, the streetlights turn on or off. Similarly, security systems use logic gates to trigger alarms when specific combinations of inputs, such as motion detection and door sensors, are met. Beyond basic logic gates, modern computers and microprocessors rely on large-scale integration of these gates to perform arithmetic operations, store data, and execute instructions. Flip-flops, multiplexers, and arithmetic logic units all stem from these foundational logic circuits. The importance of logic gates extends beyond simple operations. They are combined in various ways to create more complex circuits, such as arithmetic logic units, memory devices, and microprocessors. These gates are essential for decision-making in digital circuits, enabling everything from basic electronic devices to advanced computing systems. Logic gates are used extensively in modern technology, from everyday household appliances to advanced artificial intelligence systems. In microprocessors, logic gates process instructions and execute tasks with high speed and accuracy. Even in fields like medicine, they play a role in devices such as pacemakers and imaging systems, ensuring precise control and operation. Understanding how these gates work is the first step in grasping the fundamentals of digital electronics. Their simplicity in function allows them to be used in a variety of applications, from school projects to industrial automation. The ability to manipulate these gates and their combinations is what makes modern electronic devices so powerful. Understanding logic gates is crucial for anyone interested in electronics, computing, or automation. They form the basis of all digital technology, from simple household appliances to complex computing systems. As we move towards more advanced digital circuits and artificial intelligence, the role of logic gates will remain fundamental in shaping the future of technology. Thank you. In the next sessions, we will explore how logic gates can be combined to build more sophisticated circuits and understand their real-world implications. Keep learning and stay curious, because mastering these concepts will open the doors to exciting technological advancements.